So in order for us to see where we are going into the future, we first have to look at the present, at the current software development lifecycle. This has 6 main phases to it. We start off with a set of requirements, that is, a PRD or an ADR. We take this and start designing the overall system, the different types of databases that may be used, the languages that will be done, some of the schemas for some algorithms, database structures, things like that. Now we go into the implementation where we start building out this application or this particular product. We go through a testing phase where there's some iterations, maybe there's some refactoring as well. And then we have our deployment, usually to like a staging test net or a mainnet deployment. And then there's overall maintenance, and this cycle repeats itself. So let's look at some of the major points that we have here. There's clear requirements and ownership boundaries through each of these cycles. There's a deliberate design before the implementation, and there is governed release processes and maintenance windows through each of these stages. So what are some of the struggles or areas that could be improved here? There's slow feedback between phases. There's humans in the loop for each of these phases, and people are signing off on certain aspects of it. There's manual handoffs to create context loss. So as it's moving down the chain, are people keeping the same original idea, or are there being changes made from the initial requirements that we started off with? Verification happens late instead of continuously. So if we look at the current software development lifecycle, we go through a bunch of stages before we actually start testing out if the requirements are still the main goals. And there's iterations and opportunities for changing of those initial requirements as we're going down to the testing phase. So the verification of staying to those set goals seems to have an opportunity to be changed. So in essence, this is really strong for coordination, weak for always on, or if we're looking at like an agentic driven execution flow where this is just continuously going and a new requirement comes in, that gets updated, there's just more completion that can be verified for the subcomponents more so than having a overall application or like MVP that you are testing out. So why does the software development lifecycle at its current stage is no longer enough? Well, I mean, we have a different way of building software. The agentic, even just the completion from Google Copilot and having autocomplete, was giving developers an opportunity to build software faster. And now we had, the ChatGPT moment where we could prompt in, applications. We could prompt in the, bugs that we're running into, the overall flows. And this was another advancement to the software development lifecycle. And now we have this other area where, with the Cloud Code, opencode, as will be the focus of this course, we have tools so we can program or create the foundation or the building blocks where these agents have the tools and we have basically the workflow. So in classic delivery, each phase waits for the next handoff. The context gets rewritten repeatedly. Testing and review occur after implementation, and iteration speed is constrained by each of the boundaries or by each of these handoffs. So if we look at an agent session, it plans, there's execution, verification, repair, and these are all being fired on all cylinders. You can kind of think of this as like a piston. So the agent workflow lifecycle, it's a closed loop. So, we have an intent and a goal, and that loop is continually going until that success criteria has been met. So the core stages, intent and success criteria. What is it that we are planning to build, and what is the definition of done? Context assembly and retrieval. So we're constantly, grabbing new context and having this drive the development plan itself. Testing, planning, and agent execution. So there's like a task plan for each stage of the development of this application. And then there's also opportunities where we can consider that particular section as being done. Verification, review, critique are happening as these particular components are being done. Repair, the optimization, and redeploy as new pieces are being completed. We're deploying them and having us as the consumers of this tested to make sure that the application that is being designed by this agentic team is what we're expecting. So we have our observation and feedback, and then we're iterating this. So what changes for the engineer? We are no longer just moving work forward as the traditional software development lifecycle. We are shaping that loop. We are building out the goals, the guardrails, the tools, review points, and recovery paths in order for these agentic systems to build out these things. So not everyone who's going to start using this agentic workflow or this generative engineering principles is going to get the same outcome, because you can only get the best out of it of what you can actually teach it to do. And to always stay ahead, we're going to have different flows that might be more inference efficient, that can do a lot more work but with less inference cost. And then there's always going to be that balance. That's what keeps this whole thing honest, really. So the traditional life cycle versus our closed loop agentic workflow life cycle, right? The phases still exist, operating model changes, right? So if we look at the traditional, software development life cycle, we have, the phase sequence, we move through our stages, we have, late stage gates with our validation. Through the context, it's recreated at each handoff, like context changes as it changes hands. And failure handling, execute and requeue. So currently, we all are working in the current software development lifecycle, even though we may be adding these agentic workflows to it. So what we're really defining here is that a bug comes in, it gets assigned, and then we, requeue this up, it gets fixed and redeployed. Now, we currently do this even if you're using, agentic bots into your workflow, where, a PR comes in, you fire off an agent, it does a first pass to make sure, certain things are done. If it does find bugs, we have currently implemented that if it does find bugs, it gives you suggestions, and then the agent can go and actually fix those itself. So in a closed loop agentic workflow lifecycle, we have this over-encompassing execution loop, designs and supervises the loop. We have this continuous verification of these goals. is persisted and reused, and repair and retie are still in this same loop. So it just, keeps going until that definition of done has been reached. So traditional software development lifecycle defines the phases. The agent workflow lifecycle defines how agents move through the software development lifecycle. So the software development lifecycle is still there. It's just that now that we have these tools that are applied to the way that we are using AI as software developers, software engineers, however you want to define it, has changed. So opencode is the operating environment. So why it fits into this model: we have an agentic interface for a terminal. We have built-in tools. We can use skills. We have all these different, things that we can use. We can integrate MCP servers. We can, integrate other people's custom tools and skills. Plant agents can analyze and review before making any code changes, and a practical place to run closed loop engineering sessions, right? So it comes down to the big four, and this is the big, takeaway, is that we have context, we have, the model that we're using, the prompt that we are designing, and the tools. So the classic way of working with a chat interface is that you have your project, you're developing it, you might ask the model, I want to build out X thing, and you're kind of going through it, and it's like a collaborative back and forth. Like you're writing out code, you're plugging in your error message, you're maybe verifying a particular function, and it's kind of like this symbiotic kind of like back and forth type of thing. But once you have the tools, you are building the system that builds out that system. So it's a mind shift in the sense that you should take yourself away from the keyboard and build out the system that allows that particular application to be built. Hopefully I'm explaining it correctly, but as we go through more videos, it makes more sense. So let's look at how this closed loop structure works in practice. We have our intent. So we define the goal and the success metrics. Next, we have our context, the assemble files, constraints, guardrails, and now we can run into the execute. We run the agent using the tools and the permissions that we have defined. We verify, check tests, logs, diffs, telemetry, things of that nature. We review. So after this whole thing has gone through, we load up the application. We make sure that things are going as planned. We are managing these agents on the work that we have assigned. So these agents are working on our behalf. They know how to complete things based on our knowledge of what we would do to go to build that thing itself. And then we have this repair, retry, recontextualize, we have that iteration phase. So a good closed loop makes verification and repair part of the workflow, not a separate phase after the fact. So it's going through these things, it's finding these errors, we're seeing that things are not in the right place, feeding that back in. And as the more that the agent and your flow does this, the more better these agents will get at one-shotting. The whole goal here is to pass in our intent, our goal, our success metrics, the context, the information that the system needs in order to build what it needs to build, and have that come back perfect. That's the goal. So what's the big takeaway from this? The engineer's job isn't disappearing. Actually, I would argue that this is the greatest time to get into software development. The game has changed. It has opened up this opportunity for new engineers, new software developers to come on board and to learn this craft. Now think of it, we have billions of people around the world that will need software in order to level themselves out of poverty, right? So the reason why a lot of these tools come into existence is because there is a greater good from it. So there might be a transition period, but the overall trajectory is that there isn't enough engineers in order to build out the software that we need for the billions of people that actually need it. So the engineer's job is not disappearing. It's moving up the stack from manually pushing code through phases to designing the systems that actually build the systems, that plan, execute, verify, and improve. Design the loop, the goals, context, permissions, and recovery paths, the trust verification, not hope, testing, review, telemetry, keep the loop honest. Use opencode as the control plane. Run practical agent sessions instead of one-shot prompts, right? And that's it for the first video. More theoretical, really philosophical, but it's the groundwork and it's the foundation that we need to start thinking about. Stop writing code. We need to stop writing code. We need to allow us as engineers to build out the systems that build the system. See you in the next one.